This is the screencast for section 1.1, example 11. A word about proof. Deductive reasoning. So when somebody says, prove it, you're asking them to say without a doubt, show you without a doubt that what they're saying is true. So deductive reasoning is showing logically that something is always true. This is a very hard concept to grasp onto. We are going to practice it throughout this course and hopefully you will get better at it. Don't be frustrated at first. Just try and understand the proofs as we go through them. Example 11, proving a peculiar number fact. So the question asks us to prove that 6, the number 6, is a factor of any number cubed minus itself for every positive integer n. So in other words, 5 cubed minus 5, 6 cubed minus 6, 7 cubed minus 7, 8 cubed minus 8. Now your book in example 11 has a chart of all these numbers that are cubed minus themselves. I'm leaving that out because I want this to be more abstract. I want you to understand what proving actually means. First, I'm going to pick apart n cubed minus n and look at what it's made up of. N cubed minus n has a common factor. I can pull out an n, which leaves me with n squared minus 1. And I know with my difference of squares factors that factors into n times n minus 1 times n plus 1. If I put those in order, I actually have 3 consecutive numbers. I have the number n, 1 less than it, and 1 more than it. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Or even 6, 7, 8, 7, 8, 9, 8, 9, 10, etc. I have 3 consecutive numbers. Well, in any 3 consecutive numbers, one of those numbers has to be divisible by 3. Well, by the nature of divisibility. I mean, every third number is divisible by 3. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So one of these numbers has to be divisible by 3. Let's also look at the makeup of 6. 6 is divisible by 2 and 3. So if this factorization is divisible by both 2 and 3, it is therefore divisible by 6. Well, we already said it's divisible by 3. Now we just have to prove that it's divisible by 2 as well. So I look at this and I go, alright, if this n minus 1 is divisible by 3, it's either odd or even. 3 is odd, 6 is even. 9 is odd, 12 is even. Well, if this number that's divisible by 3 is even, it's also divisible by 2 because all numbers are divisible by 2. So let's say if n minus 1 is divisible by 3, then it is odd or even. If it's odd, n will be divisible by 2. If it's even, it itself is divisible by 2. And therefore the whole number is divisible by 6. So like let's say if n minus 1 is divisible by 3 and is odd 15. The next one, n, 16, is divisible by 2. Therefore we have a number in this composition that's divisible by 3 and a number that's divisible by 2. Therefore the whole thing is divisible by 6. Now this rule applies to n and n plus 1. If n is divisible by 3, is the piece of this that's divisible by 3, because one of these has to be, then the number, either it is even and divisible by 2, or both numbers to the side of it are even and divisible by 2. Therefore the whole thing is divisible by 6. If n plus 1 is the number that's divisible by 3, then n is divisible by 2 if n plus 1 is odd. Now number 53 goes along with this proving concept in somewhat of the same manner. Prove that if n is a positive integer then n squared plus 2n is either odd or a multiple of 4. Okay, so I'm going to look at this the same way. I'm going to take n and factor that out, so I have n plus 2 on the inside. I'm also going to look at what 4 is made up of, which is 2 2's. Well, let's see. If n itself is odd, an odd times an odd is an odd. So if n is odd, n plus 2 is also odd. 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9. So if n is odd, n plus 2 is also odd. And an odd times an odd is an odd. Now what if n is even? If n is even, n plus 2 is also even. Both n and n plus 2 are divisible by 2 because they're even. Therefore, the whole thing is divisible by 4. So what I did, the strategy I used in both of these proofs, was picking apart my starting point and my goal and trying to figure out how I can get from the beginning to the end. How can I get 2 2's or an odd out of this? Well, I have two scenarios. N is either odd or n is even. In this problem, one of these has to be divisible by 3. So therefore I figured out, well, what would happen to the other ones? If one of them is divisible by 3, the other one has to be divisible by 2, or itself has to be divisible by 2, because every third, multiples of 3 are either odd or even. Again, don't get frustrated if you don't think you could come up with these proofs on your own. Go back, listen to the screencast, and see if it comes easier to you the second time you hear it. We're going to go over more of these in class. You're just trying to create at this point a logical train of thought. Can you follow through this train of thought? Can you see where there is no room for error in this? Every step we've made covers all possibilities. This has to be true. N cubed minus n has to be divisible by 6. N squared plus 2n has to be either odd or a multiple of 4.